Welcome to the Deep Dive.
Oh.
We're diving into a pretty wild idea today. Could our universe exist inside a black hole?
A black hole universe.
Yeah. We got some interesting source material for you guys today. AI-generated summary of articles and research and videos about this topic. It might sound like science fiction, but we're going to break it down.
Yeah, it's a fascinating idea. And what's really interesting is, physicists are actually considering this. It's a real theory that they're looking at to explain some of the mysteries of how the universe began.
Yeah, exactly. So before we
Yep.
journey into the theoretical heart of a black hole, how about we just remind ourselves, what a black hole is?
Yeah, for sure. At the most basic level, a black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape. And the really mind-blowing thing is that they're not just theoretical. We've actually observed them.
Yeah, I know. They're out there. We know they exist. The one at the center of our galaxy is just it's wild to think about. But what if the Big Bang itself was the result of a black hole in another universe? That's what we're talking about.
Yeah, that's what we're diving into today. One of the most intriguing theories about this is called the white hole and wormhole hypothesis, put forward by the physicist Nikodem Poplawski.
Okay, I'm listening. What's he saying?
Basically, he proposes that when a star collapses into a black hole, it might actually create a white hole on the other side, which is kind of like an exit point. And that these two points are connected by a tunnel called a wormhole, or in physics, an Einstein-Rosen bridge.
Okay, so are we picturing our expanding universe?
Yeah.
Like a balloon inside of a bigger balloon?
That's a great way to visualize it, yeah. And this model has some pretty significant implications. First, it tackles the infamous singularity problem of the Big Bang. Instead of starting from a point of infinite density, which kind of breaks the laws of physics as we know them, it proposes a finite starting point, the size of that parent black hole.
Okay, so it makes it a little tidier.
Yeah, exactly. Plus, this model suggests that our universe might be closed and have a preferred direction due to the rotation of that parent black hole.
Wait, so you're saying that our universe might not be endlessly expanding in every direction. There might be an actual boundary.
Exactly. And
Yeah.
if that's true, it would mean that we could never travel back to that parent universe. Think of our universe's event horizon as a cosmic one-way door.
That's wild. What happens when we hit the edge? What's beyond the door?
Those are great questions. And while we don't have definitive answers, there are other models out there that try to tackle these concepts. One suggests that our universe could actually be a higher dimensional event horizon.
This is where I feel like my brain might melt a little. Higher dimensions. Event horizons we can't perceive. Walk me through it.
Okay, so think of it this way. Our three-dimensional universe could actually be the two-dimensional event horizon of a four-dimensional black hole existing in a universe that we can't even comprehend.
I'm trying to keep up.
Yeah.
So walk me through that connection between a 4D black hole and our universe.
Okay, picture this. Just like a black hole's event horizon grows, as it swallows matter, our universe expands. It's like a constantly inflating surface, but in a dimension that we can't directly experience.
Okay, I'm starting to see the analogy, but what does that mean for us, for our existence in this potential 4D black hole?
Okay, so this is where things get really mind-blowing. This model implies that the event horizon of that 4D black hole could contain information about everything that ever fell into it. And that information, in a way, could be what makes up the stuff of our universe.
It's like a cosmic memory bank. That's incredible.
Yeah, it's really a captivating idea. Plus, it provides another solution to that singularity problem, offering a different way to understand the Big Bang. And then there's the concept of infinite nesting. Universes within black holes within universes. Black holes all the way down.
Whoa. So many ideas. So we've got these two mind-bending theories, both suggesting that our universe is contained within a black hole, but in wildly different ways. It's fascinating. But I imagine there's some pretty big challenges to these ideas.
Right. You're absolutely right. There are some major hurdles that these theories need to clear before we can consider them anything more than interesting possibilities.
Okay, hit me with the reality check. What are the challenges?
Well, one of the biggest is the need for something called exotic matter.
Exotic matter.
Yeah.
That sounds like we've wandered into Star Trek.
Yeah.
What is exotic matter?
Yeah.
And why is it so important to these theories?
So for wormholes, those tunnels connecting black holes and white holes, to remain stable, they would need matter with negative energy density.
Negative energy density. Can energy even be negative?
It's a very theoretical concept, and we haven't actually observed anything like it in the universe.
So it's a big if. What other challenges are there?
Then there's the problem of infinite regress. If we accept that our universe was born from a black hole, in another universe, the question becomes what created that universe and the one before that. It creates a chain of parent universes. That could potentially go on forever.
Like a cosmic chicken or the egg.
Yeah, exactly.
Just pushing the mystery back.
Yeah.
Without a real explanation.
Exactly. And perhaps the most crucial challenge is the lack of observational evidence. We can have all the mind-blowing theories we want, but without concrete proof, they remain just that, theories.
We need some cold, hard data to back up these extraordinary claims.
Exactly.
So what kind of evidence are we lacking?
For one thing, we haven't found any conclusive evidence of a preferred direction in the universe, which the white hole wormhole model predicts. Remember that spin we talked about? Yeah. If our universe was born from a spinning black hole, that spin should leave a trace, a kind of cosmic fingerprint, but we haven't found yet.
So no sign of a cosmic fingerprint. What about the idea of a closed universe? Have we found any evidence to support that?
Not definitively. The shape of our universe, whether it's open or closed or flat, is still an active area of research. We're gathering data all the time, but we haven't reached a conclusive answer yet.
So plenty of mysteries still to unravel. But before we wrap up this deep dive, there's one more related topic I wanted to explore. Primordial black holes. Now, they're not directly related to the idea of our universe existing inside a black hole, but they do offer some fascinating insights into the early universe and its evolution.
Yes, primordial black holes. These are thought to have formed in the extremely dense and hot conditions shortly after the Big Bang. And they could be radically different from the black holes we observe today.
Okay, I'm intrigued. Tell me more. What makes them so special?
Well, unlike stellar black holes, which form from the collapse of massive stars, primordial black holes could have been created directly from the fluctuations in the fabric of space-time in the early universe. This means they could span a vast range of masses, from incredibly tiny, smaller than an atom, to supermassive, even larger than those found at the centers of galaxies.
So you're saying there could be this whole spectrum of primordial black holes out there, from tiny specks to huge behemoths. Wow, that's amazing. But why are scientists so interested in these ancient black holes? What kind of secrets could they hold?
Well, for one thing, some scientists believe that primordial black holes could explain dark matter, that elusive substance that makes up a large portion of the universe's mass, but doesn't interact with light, making it invisible to us.
So instead of being some exotic, unknown particle, dark matter could actually be made up of countless primordial black holes scattered throughout the universe.
Exactly.
It's interesting.
It's an intriguing possibility.
Plus, these primordial black holes could have played a crucial role in the formation of galaxies. Imagine them acting as seeds, pulling in surrounding matter, and eventually growing into the supermassive black holes we observe at the hearts of galaxies today.
So they could be essential building blocks for the large-scale structure of the cosmos.
Exactly.
But you said earlier that these are still theoretical objects. Have we actually observed any primordial black holes? That's the catch. As of now, their existence is still hypothetical. While there have been some tantalizing hints and indirect observations, we haven't definitively detected a primordial black hole yet. It's a very active area of research. And scientists are developing new methods and technologies to search for these elusive objects.
So another cosmic mystery waiting to be solved. It seems like every answer we find just leads to more questions. It makes you wonder what other incredible secrets are lurking out there, just waiting to be discovered.
That's the beauty of exploring the cosmos. It's a journey of constant discovery, where each new finding expands our understanding and pushes the boundaries of human knowledge.
I completely agree. It's so humbling and so exhilarating to think about all the possibilities that still lie ahead.
Yeah.
But let's bring it back to our original deep dive. We've covered some pretty mind-bending concepts today. Universes inside black holes, white holes as exits, higher dimensions we can't even perceive.
It's a lot to take in. I'm still processing it all. Yeah, it's a lot to wrap your head around for sure. But what's crucial to remember is that these ideas, while still unproven, offer really creative and potentially groundbreaking solutions to some of the biggest puzzles in cosmology, puzzles like the Big Bang and the nature of dark matter. They encourage us to think outside the box and consider possibilities that might seem outlandish at first glance.
They challenge us to expand our perception of reality and question the very nature of the universe we inhabit. If these theories turn out to be true, what other extraordinary possibilities might be waiting to be uncovered? What other mind-blowing realities could be hidden just beyond our current understanding?
It's a truly tantalizing thought, and it really underscores the importance of continued exploration, of pushing the boundaries of science and technology to delve deeper into the mysteries of the cosmos.
Absolutely. And who knows, maybe one day we'll have the technology to directly observe these other universes, or even find a way to travel between them. It's a future filled with exciting possibilities, and I can't wait to see what we discover next.
It really makes you think about the scale of it all. If our universe is just one of many, maybe an infinite number nested within black holes, where does it all end? Or does it even end?
Yeah, that's a question that's both exhilarating and terrifying at the same time. The concept of infinity is already hard enough to wrap our heads around. But when you apply it to the cosmos, it really does just stretch the limits of our imagination. Makes our everyday problems seem so small.
Right.
Yeah.
And if there are other universes out there, what might they be like? Could they be drastically different from our own, or are there some fundamental principles that govern all universes?
That's what I think is so interesting. Like, if our universe is shaped by these certain physical laws and constants, could those be completely different in other universes? Could gravity be weaker? Could light travel at a different speed? It's mind-boggling.
Yeah, some physicists propose that the laws of physics, as we know them, might just be one set of possibilities in a much larger multiverse. The fundamental constants that govern gravity, electromagnetism, and the nuclear forces could have different values in other universes, leading to dramatically different physical realities.
Oh, it's like the ultimate what if. And if the laws of physics are different, wouldn't that also mean that life, if it exists in those other universes, could be totally alien to anything we can imagine?
Absolutely. We might encounter life forms based on entirely different chemical elements, or life that exists in dimensions that we can't even perceive. The possibilities are endless, making the universe a playground for both scientific exploration and philosophical inquiry.
It makes you wonder if these other universes exist. Are there other versions of ourselves out there, living out different lives? Does that diminish the significance of our own existence? Or does it make it even more precious?
That's a profound question, and one that has no easy answer. Some might argue that it diminishes our significance, making us just one insignificant drop in a vast cosmic ocean. But I think it actually highlights the uniqueness and preciousness of our own universe and our individual lives.
I like that perspective. It's about appreciating the incredible odds that led to our existence in this particular corner of the multiverse.
Yeah, it's about embracing the wonder and mystery of the cosmos and recognizing that we are part of something much grander than ourselves.
It's inspiring. It makes you want to keep learning and keep exploring, keep pushing the boundaries of what we know.
I couldn't agree more. And who knows, maybe one day we'll develop the technology to detect those other universes or even find a way to travel between them. It's a future ripe with possibilities.
Well, we've covered some really mind-bending concepts today, from black hole universes to the possibility of a multiverse teeming with countless realities. It's a lot to digest, but hopefully it sparked some curiosity in you and a desire to delve deeper into the mysteries of the cosmos.
The universe is a vast and enigmatic place, and there's always more to discover. Keep asking questions, keep exploring, and who knows what incredible wonders you might uncover.
That's a great note to end on. Thanks for joining us on this deep dive. Until next time, keep looking up and keep those minds curious.